Hello, everybody, and welcome to day 73 of the 100 Days Python Programming Challenge. We've spoken about NumPy in the past and also pandas, but how do you differentiate both, or when do you know when to use what? Well, today is day 73, and we'll put both NumPy and pandas in the ring. Let's have a comprehensive comparison. So, do you want to learn more about NumPy and pandas? Then to the screen. Hello there, and welcome to day 73. Today I've got something exciting. I always say I have something exciting. On day 61, I believe, we spoke about NumPy, and on day 31 or so, you can check the playlist. I spoke about pandas, we learned how to clean data and the rest. And then I thought today, day 73, why don't we do a comparison of pandas and NumPy? Pandas and NumPy are essential Python library that are used for data manipulation and analysis. Overlap in some functionality, but their use case is different. So why are we comparing pandas and NumPy? We want to know where to use it, what is the strength, the limitation, and this would help you when you're coding to know what library to use for what problem. So I put a table, I found this table on the internet that shows you the use cases of NumPy and pandas. So you're performing numerical computation, you use NumPy. For data manipulation and analysis, you use pandas. For multi-dimensional arrays, you use NumPy. And for tabular data, you use pandas. And NumPy is best for the high performance math operation, while pandas you use it for organizing, cleaning, and analyzing data. So I have examples of how you use NumPy for creating a two-dimensional array. If you've not watched the video on NumPy and Pandas, you have to watch it. Check the playlist, watch the videos. So this is how we create a 2D array in NumPy. And this is how we create a data frame in Pandas. So let's go to the data structure. Data structure with NumPy, it only works with homogeneous data. That means that all the elements must be the same type. So for instance, if I'm printing, so for example, imagine I want to print an array and then I have like different types of elements in the array. When it prints out the result would be the same data type. So NumPy enforces a data type. Let me show you an example. So this is an example. You see here I have one string. When I print the array, everything becomes a string. So NumPy works with homogeneous data. Why pandas, you can have heterogeneous data in pandas. Let me show you an example of when we have an integer and we also have like an object, a string. So pandas allows you to have mixed types. So see this our age, and our age is an integer and our name is an object. And when we run this, you see it is not affected. And we use the data.dtypes to check the data type of our age and name. Watch the pandas video. And then number 3 is the performance, like which is faster amongst both of them. NumPy is faster because you are doing numerical computation due to the storage and vectorization, while pandas is slower due to additional functionality but optimizes when you use NumPy under the hood. So I'm going to do a performance test, and that is by calculating the time. We spoke about timing on day 57. You should check day 57 to learn about the calculating the time it takes your code to run. So I would have the same code for NumPy and pandas, and then we would calculate the time it takes it to run. So I would import my time to do the calculation. So I'm not explaining every part of the code because we've already talked about it on previous days. And today's video is just comparing NumPy to pandas. That's why I'm telling you the day so you can watch the videos if you want to learn about timing. That is day 57. So for NumPy, and this is pandas, we have the start time, the time, and then I'm using random of 1 million. Okay. And then I'm calculating the end time. I'm subtracting the end from the start. And then I'm also doing it in creating a series, pd.series, and calculating the sum and doing time.time to calculate the start and the end. As you can see, the time for the NumPy is lower compared to the time of Pandas. That is because the Pandas is slightly slower. And then we now compare by the operation that if you want to perform aggregates, use the np.sum, and Pandas you use def.df.sum or df.mean and np.mean, and you can do basic slicing with NumPy, and you in Pandas you can do labels or advanced selection. And missing data. In NumPy, there's no built-in function to handle missing data, but in Pandas, you can use the df fill NA or the df drop NA. So the next thing that we'll talk about is the visualization of the difference. So now we want to see the memory usage of Pandas and NumPy. And expected NumPy we have a lower memory usage compared to Pandas. So I will import system, import sys, and then we'll have an array, and then we'll get the size of the array for both NumPy and Pandas. So NP array, this is our array, and then we're getting the size of, and let's see the size. So we see that NumPy uses less memory, while Pandas uses more memory. And then finally, we'll talk about how to undo missing data. Let me show you for Pandas how you would undo missing value. So if we have this and we want to calculate the sum, nothing gets affected, nothing happen. It just calculates the sum of the integers that we have. So we have 7.0. And then if you now want to do this for NumPy, we cannot just put none there. We have to use the np.nan. So it requires np.nan before you can calculate the sum. And then when you want to now, here we just use data.sum. If you want to use for NumPy, you now have to use np.nan sum array. So you see we have the same array as before, but we can't use none. We use np.nan, and then to then calculate the sum, we then use np.nan sum. And when we run this, we get the sum. So you can see with Pandas, it's like easy to undo missing data. It just adds the data of the values that are available. So when do you use them? When you have numerical computation, you use NumPy. When you are performing data wrangling, you use Pandas. When you are handling tabular data or mixed data, you use Pandas. Or when you have fast-paced operations, then you use NumPy. So I hope with this you've learned the difference between NumPy and Pandas. Go check out the video. Let me know if you have any questions in the comment, and we shall see tomorrow. Day 74. I have something special for day 74. You do not want to miss it. That is it for this video. Do not forget to subscribe, to like, and leave a comment. Let me know if you have any questions. And as always, the link to the Jupyter Notebook is in the description. See you tomorrow.